Hello world, this is GL from GL Tech School. In this video, I'm going to teach you how to create a fire detector in Python using computer vision. So let's get started. What we're going to do in this video, we're going to create a computer system which is going to predict file and video sequences. For example, this system has main three features. Those features are it can detect file and video frames, and it can turn on alarm. Then it can send emails to file engine services to alert them. Pre-request for this tutorial, you should have some basic programming skill and a little bit of Python skill, because I'm not going to teach you any basic syntax like if conditions or for loop. So instead of teaching those, I'm directly going to dive into writing code for this project. Okay, the tools I'm going to use Python 3.6 and Opencv. Opencv is a computer vision library for C++ and Python. And play sound, I'm going to use play sound to play the alarm sound. Okay, I hope you can install these dependencies and tools by yourself. And the algorithms, I'm going to use HSV color model. HSV color model, it's simply like RGB, but it is used for development purposes. So these are the colors. So the basic algorithm is what we're going to do. We're going to search for particular color in video frame in order to track the file. For example, you can see this is the lower and upper color which is responsible for file, and what we're going to do, we're going to search for this color. So if you want to develop any effective methods, you should use yellow or SSD deep learning method for creating effective models. So in this video, we're going to only use HSV color model. So let's see. Okay, before I develop the system, I think it is very important to show you the demonstration of the whole system. I have already written this software, so I'm going to run this. So I have a simple video clip, and you can see this video has been recorded on my mobile phone. And what we're going to do, I'm going to put this video inside my system to process it. So let's see. In order to run my computer system, in order to run this program, I have to type Python and the name of the system. So let's wait. So now you can see the file is detecting, and after 10 seconds it will send. And you can see once it's the file, it turned on the alarm and it sent an email to my mail, which is the mail of the file engine services. So now you can see this is my testing email address. I got a new email, and which is from 0 minutes ago, and it's saying warning, a file accident has been reported on ABC company. So this is the message that the file engine is going to get. So this is the system we're going to build in this tutorial. Stay tuned. We're going to dive into programming. Alright guys, now we're going to write the system in Python. So I have created a folder in my desktop called fire detection in Python. I have a script file now which is empty right now, and we're going to write code inside it. And I have a video file which is we're going to process videos, and I have an alarm sound which is used to turn on the alarm. Okay, now first of all I want to import the CV2 library. Then I don't know why this window is up here. Okay, and now I have imported the CV2. Then what I need to do, I have to capture the video. In order to capture the video, CV2 provides a function called capture video, cv2.video capture. Video capture, and we're gonna put the index of the camera. So if you put 0, it is going to access your first webcam. If you put 1, it is going to access your second webcam. But according to this case, what we're gonna do, we're going to load this video clip. Therefore I'm gonna put the video name inside this. It is a movie file, so it is very important to put the extension of the video. Now the second code we're gonna write is while loop true. This while loop is going to run forever. So while this loop is running, we need to extract frames from the video. Therefore we have to write this code: red frame, then video.read. Okay, So what is going to happen, while this loop running, it is going to extract frame from this video, and the frame is going to stored here. Then there's a boolean value will be here. This boolean value is indicating whether we are getting frames or not. So it is very useful to stop, like if let is equal to false. What we're going to do, we're going to break the system. Like if the video ends, break the system. So that's the meaning of this, break the while loop. That's the meaning of the if condition. So next what we're going to do, we're going to insert this cv2.insert the window name of the window. Okay, so I'm gonna put name as output. Okay, then we're gonna put frame. So we're gonna display the frame. Below we're gonna type if wait key, if cv2 dot wait key 1, and then 0xff and equal to ORD. I think you can easily understand this code Q, and it is gonna be ended. So what is the meaning of this line of code? It means when anyone plus Q in the program. Okay, when anyone plus the Q in the program. So that is the meaning of the code. So cv2 dot destroy all windows, then video dot release. Okay, now I'm going to execute this program. I'm going to execute this simple program and see what's happening. Okay, in order to execute this program, we need to first open our CMT, and I have to activate to my environment where I have installed all of my dependencies. But in your case, if you don't use Anaconda, you can simply run it. If you use Anaconda, if you created Conda environment, you need to do this. So it's loading, and you can see the flame is working fine. So you can see the flame is working fine, but it is very big. I think it is very important to resize this flame. You know, this flame inside here, we're going to write a piece of code which is going to resize this flame. So I take flame is equal to cv2.resize. oh my god, I can't access to this resize. Then I have to put the size of the window. I'm going to resize the window into some 100,000. I'm going to resize this flame into 1000 into 600 or something. So now if you run the program, and you can see the window has been resized. So what we're going to do right now, after we completed this, we're going to detect file inside this video. So it is just a video clip, or if you put the CCTV camera, so if you access your webcam by typing 0 here, so it is going to access your webcam, and you can see my webcam will be turned on. Like that. If you want to access the second camera, we have to put 1 here. If you want to access the third camera, we have to put 2 here, and so on and so forth. So according to this video, according to this tutorial, we are accessing video from a source. Therefore, we need to put the video name with the extensor. So if you copy your file in a path, you have to put the path inside this parameter. So what we have done so far, we have resized the frame. So let's run the program to check what we have done so far. As you can see, we have resized the window, and now what we're going to do, I am going to apply a certain blur called Gaussian blur. So the reason why I'm going to apply the Gaussian blur, in order to remove some noises from the video. So if you apply this blur to the video, some noises will be removed, then the program will be worked much better. So I'm going to display the blur right now. If you output flame, it is going to output flame. If you output blur, it is going to output the latest flame which is given blur. And you can see the video has been blurred a lot. Not blurred, it's not saved. Yeah, that's why. And you can see the video has been blurred a lot. The reason we have blurred this video, we need to remove some noises from the video. That's why we have blurred the video a lot. The next, we have to convert this flame into SHV format, HSV color. So now the video is in BGR. Now we need to convert it into HSV. So in order to do this, we can do Opencv provide a function called CVT color. And we're gonna convert blur. In what format we're gonna convert? We are going to convert into color. We're gonna convert into color. Oh my god, why I can't access to this? Color VGR to HSV. Now we have converted the video frame into VGR to HSV, and if we just apply this, and we can see a different effect. You can see the video has been converted into HSV. What we're gonna do, we're gonna search for this particular color inside this video frame. So which is, you can see the file is a different color. What we're going to look for in this video. Okay. Next, after that, we have to apply our upper value and lower value. So the upper value is 18 and 50 and 50. Okay, and the lower value, upper value is, that is the lower value, and the upper value is 35, 255 and 255. So now we need to convert this into numpy array, because computer cannot work with the numpy array. Is used to, it's a numerical array structure we have to use inside Opencv to convert some kinds of flame into numerical value. So in order to convert this value into numpy array, what we need to do, we need to put the variable name, then we need to type nb.array. Then what we're going to convert the lower. In what format we're going to convert? We're going to convert dtype into unit 8 format. So we have to do it for upper also. Therefore I'm going to copy this code, and here I'm going to type upper, then upper. Okay, the next things I'm going to do, I'm going to search for mask. I need to create the mask. In order to create the mask, I need to type cv2.in range. I'm going to looking for some color. In range, what source? I'm going to use the HSV. Then I'm looking for lower and upper color. So basically what this line of code means, we are looking for these two types of color inside this HSV format. Okay, the next we need to do some kinds of thing, which is the output data. We're going to get the output data. Okay, output, okay, simply speak, it's output, and I'm going to type cv2 to bitwise. Okay, it is a confusing one, but don't worry, let's go bitwise. And what we're going to do, we're going to use the flame, then we're going to put the HSV, then we're going to put mask equal to mask. Okay, now we have created our data detector. Now the next step is to display it the screen. Okay, now if I execute my program, 1.py, which is going to do, you can see the file is detecting. We are only detecting file, the other elements are not visible in the video, only the file is detecting. The next step is to turn on the alarm, or we can simply turn on the alarm. But instead of doing like that, we need to create a threshold in order to check if the file or not. In order to do that, we have to first get the number of total. Okay, I'm going to use some kinds of code cv2 dot count cv2 dot count non zero is I'm gonna put output, which is going to give us integer value, which is going to give a numerical value. I'm going to convert it into int. I'm going to convert that value into int, and I'm going to check if it is greater than if it is greater than 15,000. Okay, if it is greater than 15,000, it is a file. Basically, what we are doing with these two lines of code, we are measuring the size of the file. Sometimes if it is a small dot, so I need to run this code. I think I should pass this here. Okay, see, the program is like execute. It's not executing. Why? Output, not output. I need to put the mask. Actually, I need to count the mask. Okay, how many are there? Okay, and if you see there's a small tiny dot, but that's not file. So you know what we're doing with this two lines of code, we are measuring the size of the file. It is very important. So if the size is going to be more than this threshold, you can adjust this threshold according to your desire. What we're going to do, we're going to print file detected. Okay, and you can see only file is detecting if the file size is gonna be, I think I have put long or not. Okay, now you can see if it's a bigger file, it is saying file is detected. Okay, the next step of this program is to implement the sound. Okay, we need to turn on the alarm. So far what we have done is we have imported Opencv and we have analyzed the frames and we detect file. So next we need to turn on the alarm. So what we have done so far, we have detected file. The next step is to turn on the alarm. In other words, play that audio. Okay, so I think it is important to explain the above code a little bit in order to understand a concept. Okay, so what we are doing here, we are loading the video in this variable, then this loop will run so many times per second. The reason we are doing frame analyzation, we are doing frame analyzation. So per second, this while loop run many times. For example, this while loop may run more than 10 times or 20 times depending on the frame size. Okay, and here what we are doing, we are getting the frame, then we are resizing the frame into 100,000 into 600, then we are applying gaze using blur. This blur will smooth the image. In other words, we are reducing noises from the image. Then we are converting to HSV. The reason we are using HSV because we need to search for this pattern. This pattern representing the color of the file. Listen carefully. Okay, listen carefully. This pattern representing the color of the file. The next step is we need to search this color in HSV. Then we can find the file. So this is how this algorithm works. We have defined the color of the file here, then we are converting these color of the file into numpy array. The reason we have converted, because in order to work with it, it is very important to convert that color, otherwise it won't work. Then you can look at this, look at this line of code. We are searching in range HSV. We are searching this lower and upper value, which represents the color of the file. Again repeating, which represents the color of the file. So next we are outputting a bitwise operator. We are playing it. Then we are calculating the size of the file, which is the total number of total, which means the size of the file. I think I have to put size, so it makes much sense than that. So size of file. Then we are, the size should be more than 15,000. I have put 15,000. You can adjust this. You can adjust that threshold. You can adjust that threshold. If you want to detect tiny file, you can put 1,000. If you want to detect a large file, you can increase the threshold. Okay. Then what we are doing, it is printing flame detected. So what's the problem is? So the next step is to play the alarm. In order to play the alarm, we can type the code here, but the problem is it's never gonna work. The reason, if we write the code here, the computer is gonna crash. The reason, like I said before, we are doing flame analyzation. This block of code repeating so many times per second, more than 10 or 20 depending on the flame size. Because if we play the audio here, the audio will played so many times, then the computer is going to be crashed. For example, if you look at the terminal, the last output of the system, you can see file detected. It's printed so many times. The reason this block of code run so many times, but it's okay for printing. But if we are trying to play this audio clip, the 11 seconds of audio clip, that's never gonna work, because this block of codes runs so many times per second. In order to sort out this problem, we need to use a technique. So first of all, I'm importing the play sound module, which is used to play sound. Then what I need to do, I have to create a variable called file reported. Okay, file reported, set to 0. Then I'm creating another variable called alarm status equal to false. Okay, so what I'm doing here, I'm just come here and type file reported equal to file reported equal to 1, not equal to 1, plus 1, which means whenever the file is detected, you need to increase the file reported value by 1. So that's the meaning of this code. Next, what I'm gonna do, I'm gonna search for like this: if file reported is greater than or equal to 1, which means file detected. Okay, which means file detected. Next, what I need to do, I need to run the alarm. I need to check for another if condition called if alarm status. If the alarm status is equal to false, we need to run the program. Okay, we need to run the audio clip here. So in order to run that, I'm going to create a small function here that play audio. Then what I'm going to do, I'm going to play sound. The name of the audio is play sound. I put .mp3. Play this sound whenever you press the set to true. Okay, so what I'm going to do here, when the file is detected, you need to increase the file reported. If the file reported is equal to 1, equal to or greater than 1, and that means file detected. If the alarm is equal to false, you need to run this function. Then after that, set the alarm status equal to true. So this means the program is never going to run again. For example, if the alarm is set 1, the alarm is going to turn on. Then it will never turn on again, because we have used a if condition to check if the alarm is equal to whenever the alarm is equal to false, it's going to run. But here the alarm status will be true. Then it will never become false again. So if we run this piece of code, so see what will happen. And you can see it's detecting the file and it needs to turn on the alarm. Yeah, it's turning on the alarm. The next step is to send email. Okay, alright, what we have done so far, we have detected file, then we are turning on the alarm. So why do we write this piece of code? We wrote this piece of code in order to prevent the replaying over and over again playing problem. For example, we're doing flame analyzation. This while loop runs more than 10 times or many times per second. In order to quit that, in order to get it off it, we are using this line of code to block it. Such as, for example, I have created a variable called file reported set to 0. Then I checking if the file, I'm increasing whenever a file whenever it detects a file in a video frame, it increases number by 1. So I'm checking if file reported is equal to or greater than 1. That means file is detected. Next, I'm going to check if alarm status is equal to false. If the alarm status is equal to false, this means when the program runs is going to be initialized to false, we need to play the alarm. Then what we need to do, we need to set it to true. If you don't set it to true, what will happen? The computer is trying to play the alarm over and over again. It's going to crash. So we don't want that functionality. So there we have mute that function, or we have locked that functions violating this if condition. So next is we are going to send email. In order to send email, we need to import smlib, smtlib functionalities or modules. Then we need to do is simulate things like this. Email status. The reason is we should do it because we know it, because the same things we're going to do here. If email status is equal to false, that means we need to send the mail. Send the email. Oh my god, email function. Send the email function. Then what I need to do, email status is equal to true, because I don't want the machine to send the email over and over again to stop my computer. So if I put this send email functions without writing this piece of code, what will happen? The computer will send the email over and over again. So it cannot be done. The program is going to be crashed. So in order to do that, we have do that. So what is the send email function? We haven't written these functions yet, so we need to write these functions over here. The video is getting too long. I think it's almost past 20 minutes. So I have written this piece of code. I'm going to copy and paste and explain what's inside it. So this is the send email functions which is executing, which we are calling over here. Over here. Then what I need to do, this is the recipient email. You need to put the file engine service email address over here. Then what you need to do, you need to set up your email address here and your password here. and your password here. Then you have to put your email address on here. When you are logging, you have to put your email address. At the same time, you have to put your email address here. System email address means your email address. The system is going to use the system is going to use a particular email address. So you create an email address, or it may be Gmail address. Okay, it should be Gmail. Then you're going to put the Gmail address here, and the password here, and the message over here. So for the privacy purpose, I'm not going to type my password. So I'm going to pause the screen recording and type my password, and I will come to the demonstration. The system has been completed. This is the complete system we are trying to develop. See, another thing you need to remember, it is very important, you can't send email directly. Okay, in order to send Gmail, you need to log into a Gmail and turn on the secure last app option. If you don't turn on that secure lock app option, you cannot send email from bot like this. Okay, it is a bot. You cannot send email like this. So in order to do that, you have to log in your email. Your email means the system email that you are going to use, and go to settings, the Gmail. If you don't know how to set up, just Google secure less app. So for example, in order to turn on secure less app, you need to log in your Gmail address, then go to your security, then after that, in the below you can see the less secure app access. So you need to be turn on. In order to turn on, you need to turn on like this. Okay, if you switch like this, you can access this Gmail account programmatically. Otherwise you can't. Okay, you have to do the settings in your Gmail account before you send emails via programmatically. Okay, that's it. That's all about it. You have to set your file engine email address, which means recipient email address, who is going to send your email, who is going to send this message to them. Then you need to type your email address and password, then your email address. That's it. Okay, then the program will automatically send emails to this recipient. So before that, you have to turn on less secure app features, which I showed earlier. Okay, don't forget to do that. Now we're gonna do the demonstration. Okay, all right guys, it's working perfectly, but there's a small issues. For example, we need to run this two function at the same time, otherwise it's never going to send the email address. For example, what is happening, it's first playing the audio. After the audio completed, it's sending the email. This is not I want to send the email first, then I want to play the audio. I can give solution in both way. We need to make a small change in code. We just need to copy and put this function above, and we need to delete this piece of code, and we also don't want this email status. Okay, what's happening here, we made a small changes in our code. It does not impact anything. We made a small change in code. We have run the mail function first of all. When the file is detected, we need to send the mail, then we have to play the audio. Okay, so otherwise I can give a solution via using threading. Okay, I'm not gonna use threading here, but easily I can do like this. So now it will work perfectly. So now I'm gonna see what's happening. Okay, all right, now the system works perfectly. Now I'm going to execute the program. Python, I think make sure to type in lowercase, then run. Okay, and so it's detecting the file. Next it's going to send the email to my email. Okay, and it's turn on the alarm. Okay, send email. Okay, now you can see it sent email. Email sent. Then I'm going to check my mail. This is my mail. Hi, I got a new mail from my testing mail. Here's my testing mail. It's saying warning, a file accident has been reported on ABC company. Okay, that's it. This is the source code. I'm also going to upload this source code on GitHub. You can download this source code and reuse it, or you can reprogram it, or adding extra features and putting or training your own model using yellow or something. You can integrate with it. You can use it for any other reasons, and that's it, guys. That's all about this, and don't forget to subscribe to my YouTube channel. Thank you for watching this video. If you subscribe to the YouTube channel, I'm going to upload many videos on the field of AI, computer visions, and also some programming. That's it. Thank you very much once again for watching this video. This is GR from GR Tech School.